what Celso just described is a fairly recently developed tool that has been rolled into the ADCIRC code. So ADCIRC is open source. That means people can look at it, look at the source code, and develop, suggest new tools, new ways to improve it, etc. So subdomain modeling is a recent addition to the ADCIRC code. And it was developed by these guys at NC State. And what I'm gonna the presentation I'm gonna show you is really just a portion of a presentation from this list. This is actually a pretty cool resource of information if you're interested in what people are doing with ADCIRC today, like what they're using it for, or how they are modifying it. This is a pretty good place to go to try to get a sense of what people are doing. So, I don't know where the NC State presentation is on here. It's somewhere. Oh, here it is, developments in subdomain modeling. But I kind of just took those slides and cut out some of the ones that I think are not, are a little bit extraneous for our purposes. So, and I guess maybe we can post this to Blackboard eventually. You have all these slides if you just go to the ADCIRC website. So this is essentially what Celso just described. It's essentially a tool for design, really, I mean, and research, but it was essentially developed for designing things like levees, engineering solutions, without having to incur the computational cost to rerun a whole mesh. The thing that Celso showed you, like putting a levee into a mesh, you need to have a fairly highly resolved mesh to be able to do that, right? If your nodes are 4,000 kilometers, 4,000 miles apart, whatever, 4,000 kilometers apart, you're not going to see a levee in that kind of resolution. So that's kind of the purpose of subdomain modeling. Okay, this is that purpose graphically depicted. So what they're showing here is, can you see the mouse? Yeah. What they're showing here are different scenarios of levee failures. There's a levee here, and they ran different subdomain meshes, introducing a failure in the levee at different points. One here, one here, one here, and seeing where the flooding happens in this city, depending on the different type of levee failures you have. Okay, so this is the way this goes. There's a big mesh, a full domain. That's what I'm going to be referring to throughout. Full domain, subdomain. That's the subdomain. So that, I think, is the coast of North Carolina. You change the subdomain inside, and as also mentioned, you want to try to make your changes at the center of your subdomain, right? Because the thing that you don't want is to have any impact at the boundary. Your boundary nodes are going to be extracted from your full domain run. That means the subdomain tools, the scripts that are running the subdomain tools, are going to record all the information at the boundary nodes from the full domain run. That's velocity, winds, water elevations, and like bathymetry. So you don't want to mess with those nodes. Okay, this is just really a slide that tells you that this is a one-way handoff. You run the full domain, and you're done with it. You run the full domain, record the boundary conditions at the nodes you want, and you don't really need to use the full domain anymore. You can just mess with the subdomain as many times as you want. Okay. This is essentially what I just described. I'm not going to get into it too much because I want to spend as much time as possible doing a little demonstration for you, but just as an overview, you start with the ADCIRC model that you have. You have your Fort 14, you have your Fort 13, you have a storm that you want to run, you have all of your big info files ready, and you take that and you generate a subdomain. You tell the subdomain tools, okay, I want it to be in this little area. I want it to be at the mouth of the Chesapeake Bay. I'm going to make a little circular subdomain mesh at the mouth of the Chesapeake Bay. I run ADCIRC on the full domain, but I need to tell ADCIRC that I want subdomains on. So I do that. I extract the boundary conditions for my subdomain. I run ADCIRC on my subdomain. This is essentially saying, okay, you run ADCIRC on your subdomain, your next step is to compare, right? You haven't changed anything in your subdomain mesh yet. You're going to compare your results from post-subdomain run to your full subdomain run. In the lower mouth of the Chesapeake Bay, am I getting the same results? I should be, right? There's no reason why I shouldn't be. Everything is exactly the same. So if everything is exactly the same, you're ready to make some changes. And then you can run on as many new subdomains as you want, applying as many levy failures as you want or whatever other thing. Okay. Yeah. What this step 8 is saying is, are you seeing any results propagating to the edge of your subdomains? Because if you are, that's bad. You're not getting accurate results if your changes are propagating to the edge. Okay, this stuff we'll get into as we go, and you can read it later on. This is an example of a run that was done, that they did on a really big mesh, on a fairly big mesh, on a approximately 600,000 node mesh. Their subdomain was around 30,000 nodes. They ran it with title constituents. And this is the comparison of CPU hours. So this was the comparison of runtime. Cores, number of cores times hours of run. Over 2,000 on the full domain, 73 on the subdomain. And you'll see that today. It just takes, it's like a tiny fraction of difference. This whole process requires you to make some changes to the 415. That's all this is showing you, but you'll see it. So they also created a graphical interface for this. My takeaway from this, and I've tried to use it on a Windows PC, if you have a Linux computer, you could probably get this to work. This is what it looks like. I can't get it to work the way that I want it to on a Windows computer, so I'm not going to show it to you today, but as I'll show you in a minute, it's available on the internet. So it's it looks good, but then it doesn't create the input files that you need to run on a Windows computer, from Windows computer. If you're on a Linux machine and running the graphical interface, you could just run on your local machine. Like I could run it on my Mac, I could run ADCIRC on my Mac, and it would work fine. But this is still in development, and I mean, they're continuing to improve it. This is a tiny example. This is a reiteration of what I just said. So I'll skip this a little bit. Okay. If you want to read more about this method, there was a paper that came out in March by John Baugh and his team of students. It's also listed at, like, there's a link to it on the ADCIRC website under publications too. And there's a user guide. I'll show you in a second. We'll go to this website. Okay, so you're on the ADCIRC website. Documentation, subdomain modeling. Takes you to the NC State website for their subdomain modeling. And everything you need to run subdomains is here. This is that user guide I just showed you on the slides. This is their latest one. This you don't have access to, but if you were an ADCIRC modeler, for instance, you would go here. You could look at the subdomain code. You could make improvements or suggest improvements to it if you wanted. These are the scripts that constitute the entire subdomain modeling tool. So you'll go here. When we get back to the lab, probably the first thing you'll want to do is go to this website and download these and yeah, and some other stuff too. Okay, this is the SMT graphical interface. If you want to download it, it's here. And then these are this is that paper I just showed you. If you want to read that, it's here. And some other older stuff they also published. So I wanted to spend most of the time here doing a little demonstration for you. And, oh, do these get passed down? Yeah, so there's a lot of steps involved in this, so I tried to put kind of as many of the big steps on here as possible so that you have something to follow while I'm doing this and write stuff down.